All right, so today we're just doing that last example I didn't have time to do yesterday. So this example 3. I think they have an example 4, but I'm not going to do that one, okay? So we're just going to do this one. So this is example 3. All right, this is, as old people say, this is a doozy. You ever hear an old person say that? Yeah, we used to say that. You guys say that? Probably not. Yeah, it's for your grandmother. Find the roots of, what would you say in place of that word today? Like, this is a, yeah, means this is really a tough one, a difficult one, something. You ever hear that word? It's fried. Minus. You writing this down? I see people not writing. Don't know why. Because this one is what? It's a doozy. It's a doozy. All right, here we go. So we're going to find the roots of this. What does that mean for the 1000th time? What does it mean when we say find the roots of something? We're basically solving for what? Solving for x. That's what we're doing. Okay, I don't know why they can't just say solve for x, but they do. They use different language. The higher up you go, they change words that mean basically the same thing as what we've said before. So find the roots of this. And yeah, we'll eventually set it equal to 0. I'm not going to set it equal to 0 right now. We're just going to find the factors first. Once we find all the factors, then we set them equal to 0 at the end, and then we solve for x, no big deal. So the last part, actually solving for x, is easy. It's finding the factors. There's a bit of an issue. So we're going to use that thing, that rational roots theorem, or root theorem. What is that? That's that p over q. Do you remember that from yesterday? All right. So what is the p in this situation right here? There's one number that's considered the p, the 3. All right. It's actually not just one number, but you're finding the factors of that one number. Okay, that's what I should have said. So what do we have? What times what is 3? Well, plus or minus 1 and 3. That's it, right? So that's nice. All right. What's the q? Where do we look for the q? The leading coefficient right there. So that's the 2. So what's the factors of that? Plus or minus 1 and 2. All right, so that helps out a little bit, right? We don't have a million things to choose from, so that's kind of nice. So let's list the p over q, all right? Because that's our possible factors of, is that the word I want to use? Yeah. Yeah, I guess we could say that. Our possible factors, all right? So let's do it. What is it going to be? It's going to be 1 over 1, which is 1. Then 1 over, I tell you what, let's write the fractions last and the whole numbers or the integer numbers first, okay? So it's plus or minus. So 1 over 1, then what? 3 over 1. And then it's 1 over 2, which is 1/2, and then it's 3 over 2. Did that cover everything? Yep. There's 4 of them, right? And yeah, let's start plugging some stuff in. Hopefully, we don't get through all of those and have to end up doing like -3/2. Most of the time, it shows up pretty early, all right? You might have to try 2 or 3, 4 times. I think yesterday, didn't we do one where you had to try like 4 times if we found it? I think this one actually works out pretty nice. So I would start with 1, positive 1. So what does that mean? That means we're going to go f of 1. Remember this? I mean, that was your homework, right? You had to do stuff like this on your homework. It wasn't quite this difficult, though, with the x to the 5th. I don't know. Maybe you had one. Maybe you didn't. You had to the 4th. Okay, yeah. We did one to the 4th yesterday, I believe. But today we're doing to the 5th, which means just a little bit more work. It's the same thing. We're not doing anything really different. We're just doing a little bit more of it. All right, so let's put a 1 in here. Can we do this in our head? 1 to the 5th is 1 times 2 is 2, plus 3 times 1 is 3, minus 6 times 1 is minus 6, plus 6, minus 8, plus 3. And somebody add all those up. Yeah, so that one and that one goes, right? That's a 6, that's a 2, that's an 8. Minus 8 is 0, yes. Yay, first one, all right? I love it when it's the first one, all right? Makes it Nice and easy. So what does that mean? That means that, what's a factor? X what? Minus 1 is a factor. Yes? All right, so when it equals 0, it means it's evenly divisible. This thing right here is evenly divisible by x minus 1. So when I do the division, I should come out with a remainder of 0, correct? Yes, Mr. Hamrick, that's correct. All right, so what am I going to do? I want to find out what's left over after I divide this. All right, so let's do the synthetic division. So what am I dividing by? A 1, that's correct. Because remember, this is x minus, what letter do we use? K, I think. X minus k. So that's the k that goes right there. And now, how do we do the division? Take all the coefficients, list them. This should be piece of cake. Anybody say that anymore? Oops, what am I doing? Piece of cake? Man, that's piece of cake. Which means that's pretty easy, right? So a doozy and a piece of cake are opposites of each other. All right. So let's do this. Bring this down. That's a 2. Everybody's got this part down, don't they? Yes? Maybe? All right. 1 times 2, 2. Add them up, 5. Multiply, 5. Add them up, negative 1. Multiply, negative 1. Add them up, 5. Multiply, 5. Add them up. Multiply, add them up. There we go. And it ends in a 0. What happens if it doesn't end in a 0? You did something wrong somewhere, okay? You either picked the wrong number right here or you didn't do the synthetic division correctly, but you should end up with a 0 right there. Oh my goodness, this is crazy. Now, what I did... Oh, you know what I did? No, that's fine. Yeah, okay. I was going to say I kind of cheated a little bit, but I did not. I did not cheat. So let's write this down. What's my, this was x to the 5th, so what's this going to be? It's going to be x to the 4th. It always goes down 1. Or you could have started from the right, correct? And say that's your remainder, or sorry, yeah, that's your remainder, that's your constant, x squared, x cubed, x to the 4th, right? So let's write it. So this is going to be 2x to the 4th plus 5x cubed minus x squared plus 5x minus 3. What is that? That's when I took this whole thing right here, that thing with the x to the 5th, and I divided by an x minus 1. This is what I get. You with me? I'm going to put this in a little box. I'll save this for later. All right? I'm not going to write it down every time. Now we just got to go through the same routine. Now we have something with an x to the 4th. Now we just do that same thing again, that p over q. Let's just do it. Same numbers, aren't they? Except, yeah, same numbers. Hold up, let me see. Yeah, same exact numbers. I'll just write it down again. So what is the p? Plus or minus 1 and 3. And then the q, plus or minus, plus or minus 1 and 2. So what's my p over q? It's 1, it's 3, it's 1/2, and it's 3/2. Plus or minus, of course. Because sometimes the positive doesn't work. Sometimes you have to go to the negative. So we're using plus or minus for all of these. So now, where do we start? Just like we did on the last one. Start with a 1. All right? So now there are some times, though, like if this was all plus, and I put a 1 in there, a positive 1, do you think there's any way I can get a 0 out of it? No, but you do have a couple minuses in here, so maybe there is a chance that this will add up to 0. Would you agree? But if they were all positives, everything was being added, and you stick a 1 in there, you know it's not going to go to 0 because there's no negatives, right? Does that make sense? All right, but in this situation, let's give it a shot. Let's put a 1 in for this. So this is what? 2 times 1, which is 2, plus 5, minus, what's that? Just a 1, right? Because the coefficient is it's 1x squared. X squared is 1, so it's minus 1. Plus 5 and minus 3. What does that come out to be? Let me see my thing. Oh, you know what? That was kind of dumb. Well, it wasn't dumb. But 1 probably was, I did cheat a little bit. 1 was probably not the best option because we already tried 1 in the other one, so x minus 1 is already a factor, isn't it? So we already know that x minus 1 was a factor, okay, of the first thing. So, because this does not, what's that? 7 minus 1 is 6, and 2. No, that's not equal to 0, okay? You could try negative 1. I'll tell you, this is what I was saying when I was cheating a little bit. Negative 1 won't work either. All right, you can plug it in, do the work. I'm just trying to save a little time here, but you would try it, okay? So put in f negative 1, and that's not going to work. Let me just double check. That's correct. So that won't be 0. You can try it. Stick a negative 1 in there. It's not going to be 0. So what's the next number I would try? Let's try a 3, okay? Let's try a 3 and see if that'll work. So f of 3. Now, we're going to have to do a little work with this because it's not just a 1, so it's a little tougher. So that's going to be what? 3 to the 4th plus 5, 3 cubed minus 3 squared plus 5 times 3. I could already tell you this is going to be way bigger than 0, isn't it? Yeah. Minus 3. Would you agree with that? This comes out, I didn't even say what it comes out to be, but it's going to be huge. Right, look at this. 3 to the 4th. What's 3 to the 4th? Well, what's 3 squared? 3 squared is 9, and another 3 squared is 9. 9 times 9 is 81, so 3 to the 4th is 81. That's what, 162? So that's super big. This is going to be pretty big. And look, I'm only subtracting just a little bit from it, a 9 and a 3. Is there any way this is going to be 0? No. All right? So I don't even have to go through the whole thing. All I care about is is it 0 or is it not 0? If it's not 0, try the next one. Make sense? Just trying to streamline it just a little bit. So let's try f of negative 3. Hopefully we don't have to get into these fractions because that's really going to be ugly, isn't it? All right, but it could still work. So let's try negative 3. So it's 2 times negative 3 to the 4th plus 5 times negative 3 cubed minus negative 3 squared plus 5 times negative 3 minus 3. And you work all that out. I'll save you the work. It does come out to 0. Yay. All right, isn't that fun? All right, comes out to 0, so that works. You can do the math yourself. But that does work. So that means what? What's a factor of this thing right here? What is it? X what? What's a factor of this? X plus 3. Very good. So x plus 3, I'm going to write it down just so we don't forget, is a factor. So I'm going to put a box around that as well. Remember, I got a box around that x minus 1. I got a box around x plus 3. So both of those things are factors of that original 2x to the 5th thing that we had, that polynomial. We good? So now what are we going to do to this? Let's find out how many times it goes into it. So what do we put on the outside in that little half box thing? Negative 3, right? So whatever we put in for this, you're going to put in out here. Right? And then let's put the coefficients. We're putting these coefficients in now. So it's a 2, 5, negative 1, 5, negative 3. I told you this problem was going to be a little bit tougher. But really, I don't know if it's tougher. It's just longer, really. That's all it is. And I'll drop this thing down. That's a 2. And then let's go through our routine. Negative 3 times 2 is negative 6. Add them up, that's negative 1. Multiply them, it's positive 3. Add them up, it's a 2. Multiply negative 6. Add them up, negative 1. Add them up, or no, multiply them, and then I'm getting all my adds and multiplies. Multiply 3, add them up, 0. Yay, it's a 0. All right, that's always nice to see, isn't it? So you're probably doing something right if that ends up in a 0. So what's this going to be? Remember, it was 2x to the 4th, so what's this one going to be? 2 what? X cubed minus x squared plus 2x minus 1. We good with that? All right. Let's see, what did I do next? Oh, okay. Oh, I learned something watching a YouTube video the other day that I did not know before. So what we're doing is we're taking this thing right here You could do what we just did with that P and Q thing if you wanted to, just stick a number in, see what's going to be a factor of it. But there's probably a better way to do this. What's a better way to factor this? Maybe we could factor by grouping. Does it work, factoring by grouping? Well, here's a little key. I never knew this before. I knew how to factor by grouping, but I never knew this before. If you take this coefficient and divide it by this one, what do you get? Negative what? 1/2. And then you take this coefficient right here, divide that by the one that's just to the left of it. If they're the same, are they the same? Yes. If they're the same, then you can factor this by grouping. I never knew that before until just the other day. I was watching a video on this. All right. So I can factor by grouping. What does that mean? Factor by grouping. All right. It means that I can take this, and I can find a common factor with both of those. We've done this before. Maybe you didn't remember the grouping. Did I talk? I've talked about that, haven't I? Factor by grouping. Yes? No? Anybody here today? I hate this being last period. This is the worst. Come on, wake up. Have I done factor by grouping? Do you remember that phrase at all? Okay, watch us do it. You probably will remember it. Yeah, we did it because remember you had stuff like this. I'm just making these numbers up. I don't know if it's going to come out right or not. Plus, 4. What if you wanted to factor something like this? What did we do? Remember we took that 3 times 4 equals 12. Then we had to find out what times what equals 12. And then the same two numbers add up to the middle one. And then you split it up. Remember we made that negative whatever, 5x plus 1x. That was factor by grouping. So yes, we have done it before. Maybe you just don't remember the phrase. But that's what we're doing here. So if I group these first two together, is there something in common with both of these? Yeah. A what? Not just an x, but a what? An x squared. So let's factor out an x squared. Okay? So what do we have left? 2x cubed divided by x squared is just 2x. Factor out an x squared from this, it's a minus 1. That's nice, because look, see this right here, 2x minus 1? So what can I factor out? Well, really nothing, but just to make it look nice, I'll factor out a 1. What are we left with? 2x minus 1. So this is factor by grouping. And then what's in common with both of these? A 2x minus 1. Let's factor this out of this. So if I take this and divide it by 2x minus 1, what am I left with? X squared. If I take a 2x minus 1 out of this, what am I left with? A plus 1. Now it's factored. I'll let you sit and think about it for a second. Here's another old person thing. Man, I just can't believe I'm so old now. I was going to say sit and stew over it. You ever hear anybody say that? Giving you all these old terms. Talk to your grandparents, all right? Or even your parents, maybe. Sit and stew over it. Nobody's heard that before? All right? You know, like a soup would stew, right? You let it just kind of boil for hours and hours and hours, right? And yeah, that's why it's called a stew, right? So you stew over it, all right? Anyway, so there you go. So what is all this? Well, these are factors, aren't they? These are factors. So we are ready to list all the factors. Can I factor anything else? Can I factor x squared plus 1?
X minus 1, x plus 1.
But then that would be a minus 1. If that was minus 1, that would work. But a plus 1, the answer is no. Okay, you can't factor this. So you're done with all your factors. All right, so I've been putting boxes around all my factors. Let's not put a box around this. That might confuse us. All right, so what are all my factors? What was the first one we did? Seems like ages ago, doesn't it? X minus 1, and then x plus 3. So let's list them. Let's just keep going down, I guess. So x minus 1 was one of them, right? What was the other one? X plus 3? Yes? What else?
X minus that.
Well, 2x minus 1. It's just asking for factors, not solving for x just yet, okay? And then what's the other one? X squared plus 1. Remember I said at the beginning, what are we going to do at the very end? We're going to take all those factors and then do what to them? Well, set them equal to 0. All right, because I want to find the roots. I want to find what x is. Well, We're going to see. There should be. It's a good observation, actually, because I was about to ask that. If it's 2x to the fifth that our first polynomial started with, how many answers should we have? 5 of them. But I only got 4 things here, don't I? But just watch, all right? What are we going to do with each of these? I'll show you every little step here. So we take the x minus 1, what do? Set it equal to 0. We should be able to do this in our head, but it's this one right here that I really want you to see. All right, so this is x plus 3 is equal to 0, 2x minus 1 is equal to 0, and x squared plus 1 is equal to 0. That's easy stuff right there, right? Everybody knows what to do there. Then we just solve for x. What's x here? 1. What's x here? Negative 3. What's x right here? Add a 1, divide by 2. What is that? It's 1/2. Okay. Are you recognizing any of these numbers right here? These are all those P over Q numbers, okay? What about this? This is where it gets a little weird, all right? I subtract a 1, right? So I have x squared equals negative 1. But now what do? I got to square root both sides, plus or minus. What's this give me? X equals plus or minus what? What is the square root of negative 1? It's I. Very good. It's I. There's my 2 answers. So how many do I have? I got 1, 2, 3, how many? 4, 5, right? Because I got a plus I. If you wanted to, you could say x equals positive I and x equals what? Negative I. So there's 1, there's 2, there's 3, 4, and 5. And there you go. So I could put any of those in for that original polynomial, that 2x to the fifth, blah, 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 blah. I could put any of those into there, and it's going to make that polynomial equal to what? To 0. That means they are the roots. They are the zeros. That's another way you could say roots, okay? They are the zeros of my polynomial. They're the roots. You could say that's my answer, my solution. That's what x is equal to. Any of those things kind of mean the same thing. Everybody with me? All right. And then there you go. That's your answer right there. Let's do this. I was thinking about not doing this, but I'm going to try it. This is something I just learned, okay? I'd never heard of this before, so I just learned it the other day. But I got good notes on it, so I should be able to figure this out. How many real solutions do I have? Right here. How many real solutions? I got 5 answers, okay? How many? I got 3. 3 real solutions, correct? What are these? What would I call these solutions? I have 2 what? Imaginary solutions. Okay? With me on that? Okay. How many positive real solutions do I have? I got 1 and 2. So I got 2, I'll just put it right here. 2 positive real solutions. How many negative real solutions do I have? This is a negative 3. I got 1. All right, you with me on that? So this little thing I'm going to show you, hopefully I'm going to show you, because again, it's kind of new for me. I just learned it. It's not that hard. You could always just do this and figure out that, but there's this thing, it's called the Descartes rule of signs, and before you even do the whole entire problem, it will tell you, this little thing we're going to do, and I'm going to do it just in a couple minutes here, okay? This little thing that we're about to do will tell you how many positive real solutions are you going to have and how many negative real solutions you're going to have and how many what? Imaginary solutions that you're going to have before you even do the problem, all right? To tell you the truth, since it's new to me, I don't really know the benefits of it. Because they're going to ask you to solve for it anyway, right? But if you look at the problem, it might say I don't know what it says exactly. I don't have it right in front of me, but it might say something about, tell me the nature of the solutions or something like that. I don't know. What does it say? Alua, you got the book in front of you? What's like on that last little section that I'm going to sign today? What did it, how does the question read? No, for like the last set of problems that I'm going to give you, right? So numbers 17 to 22. Look at the exercises. 17 to 22. What's it say? Everybody hush. Okay. Find the number of possible, say that again, the possible what? Positive real zeros and negative real zeros. Does it say anything about imaginary? I don't think it does, but we're going to do that anyway. Okay? So here's what we're going to do. Everybody watching? So this is called Descartes' rule of signs. So Rene Descartes. Anybody hear that word before? I taught it to you guys. Who's Descartes? Rene Descartes. He's French. What did he come up with that we use all the time? What? Coke? Is that, you say Coke? Look, this thing right here. Remember, that's Cartesian plane. Remember the Cartesian plane? Came from this guy. All right? Yes. All right. So that's him. You can look him up if you want. Let me write down that polynomial that we started with again, since it's way up top. It's, what is it? 2x to the fifth plus 3x to the fourth minus 6x cubed plus 6x squared minus 8x plus 3. All right. I hate when I teach something for the first time. I've never taught it before because I'm not like 100%. But I got this. I think I got this because I went over it several times. Let me just look at my notes real quick here. All right, the rule of signs. The reason they say the rule of signs is because we're looking at the signs. So if you look in the book, you ready to go? You do. Where are you going? Is there a note or anything? Or?
No, I got permission from my parents.
Well, school didn't tell me you were leaving. They usually do. Anybody else get permission to leave? Yeah, that's what I would do. My parents said I could leave too. No, I probably wouldn't do that. I feel guilty the rest of the week. All right, so watch what we're gonna do. Let's do this in a different color. What I want to do, and this is, I'm just trying to make it where we live, okay? If you look at the description in the book of the rule of signs and you read it, you're like, what in the world? So I'm not going to do that. I'm just going to try to explain it as easy as I possibly can. What I want to do is I want to go from one term to the other and see if there's a sign change. So what's the sign of this first term? Positive. This is positive. Is there any sign change there? No. The book puts yes or no. The guy I watched on YouTube puts zeros and ones. I like that better. All right, so is there a sign change from there to there? Is there a sign change? This is positive, this is negative. Is there a change of signs? Yes, that's all it is, just yes or no. All right, so there is one, so I'm going to put a 1 right there. All right, is there a change of signs from here to here? From there to there? Did we change signs? Yes or no? Yeah, we did, so put a 1. All right, from here to here. I went from positive to negative. Is there a change of signs? Absolutely. What about from here to here? Is there a change of signs? Yes. Okay, so what I'm looking at for how many sign changes did I have in that whole polynomial. That's why I put the 1s there. How many sign changes? 1, what? 2, 3, 4. So there's 4 sign changes. Everybody good with that? All right. So that's the f of x. Now what I'm going to do is I'm going to go f of negative x. All right. And so what does that mean I'm going to do? I'm going to put in negative x every place you see a x. All right. So what's this going to be? This is going to be 2 times negative x to the fifth. You with me? Plus 3 times what? Negative x to the... Actually, I probably should put this outside the parentheses. I didn't there, but that's okay. Minus 6 times what? Negative x to the third plus 6 times negative x squared minus 8 times negative x, and then just plus 3. So again, I'm going to do the same exact thing, but now I'm doing it with f of negative x. Let's just write down, let's see what I did. Let's just write down our signs. That might be easier. I didn't do this in my notes, but now I'm looking at it, and it might be a little bit easier way to do it. So what are my signs right here? Negative x to the... you know what? I didn't. Even though it comes out to the same thing, I really should have done this. There. That makes me feel better. Okay. Negative x to the fifth comes out to be what? Positive or negative? If I have negative to the odd power, anybody here? It's negative, I'll tell you, okay? I'll quit asking you questions. Nobody wants to answer me, so. What's this going to come out to? Well, here I go again. This is going to come out to a positive, correct? This is going to be, what's this going to be? Negative times a negative, which is positive. This is a positive, this is a positive, and this is a positive. So let's do what we did before. How many sign changes? You can just look at it. From there to there, that's 1. What about the other ones? None of those change signs. So those are all zeros, right? So how many sign changes do we have here? We just had 1 sign change. All right. So how many changes did we have altogether? Total sign changes. Yes. By the time you went through all this, the way I look at this is my personal opinion, okay? Maybe somebody smarter than me could say what the benefit of this is, but my opinion is you could probably do that whole entire problem that we just did by the time you figured out how many positive zeros are we going to get, right? Or positive real zeros are we going to get, and how many negatives we get, how many imaginaries we get. By the time you go through all this, you could have figured it out by just getting the answers. So that's why I debated whether even to show you this, but I'm going to show it to you anyway. So, oh, by the way, here's a weird thing. If you look at the definition, of this rule of signs kind of thing, when it's just f of x, that means that there's 4 positive. Okay, there's 4 positive real zeros. Okay, real zeros. Now, this thing says also you keep going down, and this is part of the rule, okay? You keep going down to the next even one, to the next even one until you reach 0. So what's the even one just below 4? 2. What's the next even below 2? 0. So these are possible. Again, these are just possible answers. We could have 4 positive real zeros. We could have what? 2 positive real zeros. We could have no positive real zeros. So those are possibilities that we have. All right? So what about this? What about the negatives? These are positive real zeros. This is what? We have 1 negative real zero. And you can't go to the next odd below that because you'd be under 0, right? And you're not going to use 0. So those are my possibilities. So let's make a little chart. So I'm going to write down all the positives, the negatives, the imaginaries. I haven't even talked about that just yet. And then the total. All right. So the total is 5, right? There's 5 possible answers. Okay. What did that first thing we do with that sign change? It said we could possibly have 4 positive answers. okay? It also said when I drop down an increment to the next even number, when I drop down to the next even one, I could have 2 positive answers, yes? Or I could have what? 0 positive answers. These are my possibilities, right? Don't know which ones just yet. What about the negatives? There was only one possibility, right? I can only have one negative. And I can only have one negative if there's 2 positives. I can only have one negative if there's 0 positive. So if I had a total of 5, how many imaginaries could there possibly be? If I had 4 positive answers and 1 negative answer, how many imaginaries could I have? Remember, the total is 5. I got 4 and 1, right? 0. You see that? What if I had 2 positive answers and 1 negative answer? How many of these could I have? I could have 2 imaginary answers. What about this? What if I had 0 positive and 1 negative? How many imaginary answers could I have? These are all, again, possibilities. All right? And now, the problem with this is I could have either this, I could have this, or I could have that. How do you know which one you're going to have? Well, it's not guessing. It's actually do the daggone problem, okay? If you do the problem, then it'll either be this, it'll be this, or it'll be this. Well, we've done the problem, haven't we? Remember what we got? We got x equals what? 1, negative 3, positive 1/2, positive I, and negative I. So we did that. So which one of these? So one of these does work. Which one do we get? The middle one. We got 2 positives right there. We got 1 negative right there. And we got what? 2 imaginaries right there. So the only thing this thing tells us, again, somebody that knows this better than I do might be able to figure out, but I watched a lot of videos on this. I read the book on this. And that's really all I can see, is this just gives you the number of possibilities. All right? There's really no other way that I can see at this point where you can narrow it down to this without solving for the thing. So that's what I meant at the beginning. You understand what I mean at the beginning? You might as well just solve the thing and then see how many negatives, how many positives, how many imaginaries, because you're going to have to solve for it anyway. So that whole thing that I did with that Descartes rule of signs, I wanted to show it to you because... Okay. So the stuff that I just showed you, if you take another course somewhere, you go to college and they talk about the Descartes rule of signs, then you're like, at least you'll have that in the back of your head. You're like, oh yeah, I remember Mr. Hamrick talked about that thing. Maybe if you take calc next year, maybe they do this. I'm not really sure. But at least I wanted you to be aware of it, that it exists, that maybe people use it, I guess. All right, I guess they do. They wouldn't put it in the book if they did it. So, but what I care about is what we did at the very beginning, okay? I care that you do what? Just find the zeros, find the roots, find the answers, solve for x, okay? That's what I care about right there. Then you can always look at it and say, oh, okay, I had 2 positive zeros. I had 1 negative 0, and I had 2 imaginaries, all right? There you go. All right. So, what's your homework tonight? It's 17 to 22, is that right? Yeah, so it's the same lesson. You're just doing 17 to 22. It's not that many, 6 problems. All right, and it's section, what is it? 44B. Okay, we'll call it 44B, 17 to 22. Last one was 44A. I said I would try to have time to go over that homework for you, so you just want to wait till tomorrow or turn it in now or what? Just wait till tomorrow because I'm going to go over it anyway. I just have to give it back to you. So if you turn it in, thanks, but just put it in a folder somewhere and wait for tomorrow. Then you can turn it in tomorrow. We'll go over both of those tomorrow and see how that works out. Yep, just going over homework. We're taking a quiz on Thursday. All right, today's Tuesday, so we'll review tomorrow and take the quiz on Thursday. And then Friday, hopefully we'll start another lesson.